Okay, so I want to do a separate video for this question because it's a little bit different. All right, assume that scores on the verbal portion of the GRE follow a normal distribution. So as soon as we hear that, we know that our normal calculations in Excel are in play. The mean is 151, standard deviation 7. Quantitative portion has scores follow a normal distribution 153, 7.67. Okay, so read carefully here. Quantitative reasoning is what this is asking about. So it's the second two numbers, right? The quantitative portion. So the mean is 153 and standard deviation 7.67. Find the score of a student who scored in the 80th percentile. Okay, so try to consider what that means here. I lost my slides. Let me get those normal distribution slides up here again. They'll be helpful to look at in our handouts, because this is asking a slightly different question than what we were talking about before. Okay, so I just want to look at let's look at a basic. Here's a normal distribution, nothing written here, but they were telling me here, right, what that mean was and what that standard deviation was. If I can bring it back up real quick. Right, the mean here is 153 and standard deviation 7.67. So what we mean is that 153 lives right here. So this number here is 153, and if I go 7.67 above that to like 160.67 or 7.67 below that, that's 68%, and so on. But they're asking us, what score would somebody have, right? What would that score be down here? I don't know what it is. If they were in the 80th percentile. So what they're saying is that 80% of scores are below this person. So this is giving us the opposite of what we were doing before. Before we were getting those probabilities and percentages. Now they're giving it to me, and I got to go back the other way. All right. So luckily Excel does this type of problem as well. Again, as long as you know the mean and the standard deviation, all these normal distributions follow the same rules. So our mean is 153, and the standard deviation is at 7.67. So we want to know, what would somebody's score be? What would their actual score be if they were in the 80th percentile? So we go equals, start typing in normal, but notice you have this normal inverse. That's exactly what we want. We want the opposite of what we've been doing. Okay, so it asks me for probability. All right, so my probability is going to be 0.8. All right, probability that somebody falls below that. The mean was 153, and the standard deviation was 7.67. Okay, and it tells me there, so somebody who is at the 80th percentile, that should make sense to us, right? 153 is average. Okay, 80th percentile is going to be above the mean, so 159 is above the mean. And it's a little bit less than a standard deviation above, right? One standard deviation above is the 84th percentile. So 159.455. I don't know how many decimal places. 2 decimal places. So $159.46. Okay. Find the score of a student who scored worse than 70% of the test takers in the verbal reasoning section. So now we're talking about the 151 and the 7. And this person scored worse than 70%. So try to picture what that means. All right. This person scored worse than 70%. So where does their score live? That's below average, right? In fact, it lives right here, right? If they scored worse than 70%, then the number that we need and we use is going to be the guy living here, which would be 30%. If you score worse than 70% of everybody, you're at the 30th percentile. So that's the number that we would have to use to work our way back to this individual's score. Okay? And remember your mean and standard deviation. They are 151 and 7 for this. So we go backwards. We want equals. We start typing in norm, and we want that inverse norm. Okay? But this guy's going to live at the 30th percentile with a mean of 151 and a standard deviation of 7. So 147.33. Okay, so I think that's going to be helpful. You go back and forth in both directions. The rest of the normal probability questions, these are like the first two, except instead of a mean of 0 and a standard deviation 1, we're doing the same thing, but just use the actual numbers that they're giving you and find those percentages, right? The mean and standard deviation won't always be 0 and 1. They might be something different based on what they've given you. Okay, so these are going to be the basic normal distribution problems that we did in question 1, just different mean and standard deviation because you're trying to find percentages, right? When you're given the percentage and you're trying to find a raw score, that's where you're using your inverse setting.